Welcome to week 3 of virtual learning. You have one video this week. I skipped a few lessons because, again, we just kind of need to prioritize some of the concepts that we're looking at over the last several weeks of school that we have. And especially given that we're only doing 1 to 2 lessons a week, we're not going to see every single lesson. However, lesson 9.7, I think, is a really important lesson for us because it's something you will see in future years of math as well. Again, I would suggest you print out the guided notes and copy these notes down. If you don't have a printer or copier that works, you can also just write these on notebook paper. That way you can refer back to them later when you go to do the practice sheet and then also go to answer the second assignment, which will be something where you will write out an explanation. So in lesson 9.7, we are dealing with independent and dependent events. So when we've talked about probability before, we were looking at the probability of one event occurring. So you have a jar of marbles. What's the probability that when you select a marble, it's a red marble? That's one event. Or what's the probability that it's a red or blue marble? So again, you're still only choosing one marble, but what's the probability that that one marble is either red or blue? So in this lesson, we're going to be talking about composite events. These are events that consist of one or more simple events. So we are looking at several events occurring. Now, we're only working with independent and dependent events here. There's also mutually exclusive events, which we do not talk about in this lesson. So that could be something like selecting a queen or a jack from a deck of cards. We could be looking at something like that. But some examples include selecting a red marble and then selecting a green marble. That's the kind of problem that we're going to see in this lesson. Now, an independent event means that I select the red marble, I put it back, and then I select a second marble. So what's the probability that that second one then is green? We'll talk about dependent events as well, meaning let's say I select a red marble, I don't replace it, and then I select a green marble. What happens is the probability of the second event changes because I have less marbles in that jar. This second example is one of those mutually inclusive and exclusive events. So I don't really want to talk too much about this. That's something that you will see probably next year, and if not next year, then definitely in high school. So I've already, discussed a little bit of the differences between independent and dependent events, but you're going to see a lot of times these are both used when you select more than one item. So you're going to select 2 marbles or 3 marbles or 4 marbles from a jar. The word and is typically going to be used, or it might say then. A lot of times though we'll see and versus or. Or is where you're just selecting one marble or one item. What's the probability that it's this color or this color or this or that? For and, it means, or then, you'll see that sometimes. We're selecting one and then another. And to find these, you're going to multiply. Whereas in our previous lessons, we were adding probabilities. So if I said, what's the probability of selecting red or blue, you'd add the number of red to the number of blue. That's different than saying, what's the probability of selecting red and then selecting blue. That in that situation, you are selecting 2 different marbles. So let's talk a little bit about independent events to start. Independent means the outcome of one event does not affect the outcome of the second event. You're often going to see the phrase with replacement, meaning I replace the item or the marble. For example, Suli selects a marble from a bag, she replaces it and then selects a second marble. Those are independent events because my first selection does not impact the second selection. The probability of 2 independent events will look something like this. P and then A and B, or A then B, you'll sometimes see. We find the probability of A, multiply it by the probability of B. So basically find the probabilities of each of those events and multiply them. Now, dependent events is when the outcome of one event does affect the outcome of the second event. This occurs when the item is not replaced. For example, Irene selects a marble from a bag. She does not replace it and then selects a second marble. What happens is because she doesn't replace it, she now has less marbles in the bag, so the probability of the second event changes. So you still see it a really similar way. It'll say the probability of two dependent events, P of A and B, or A then B. The probability of A stays the same, just like it was up here, but the probability of B is following A. So a lot of times what you're going to do is decrease your denominator by 1 each time because you have one less marble. We're not taking all of those colors out for A, but you're taking one marble out, you're not replacing it, and now you have one less marble. And we'll see some examples of that and give you a chance to try some independently as well. All right, so let's do some examples. We're going to begin with independent events. And I do specify this, by the way, on your practice so that you know which are independent and which are dependent, even though you should be able to determine that difference. But I know we're not here, we're not in class, so it's a little bit harder to understand some of these concepts. So the directions: a jar contains 4 blue marbles, 3 green marbles, 5 yellow marbles, and 8 purple marbles. Once a marble is selected, it is replaced. The first thing you want to do is calculate or figure out how many total marbles we have. Take a moment and do that. All right, hopefully you got that we have 20 marbles. The first question is, how do you know that this represents an independent event? Well, it says in the directions that once a marble is selected, it is replaced. And if that marble is replaced, this is going to represent an independent event. So we have 3 examples using these directions. Find the probability of blue, then yellow. It might be written as find the probability of blue and yellow, but this means what's the probability I select a blue marble and then I select a yellow marble. So basically, find the probability of selecting blue, find the probability of selecting yellow, and multiply them. So for a blue marble, that's 4/20. For a yellow marble, that's 5/20. I did take a moment and reduce them using my calculator. You don't have to. You could simply plug in 4/20 times 5/20. Now, I know some of you still don't have calculators at home. If you haven't gotten one yet and you can get out to get one, it would not be a bad idea to do so, obviously safely. But you can also use calculators on the computer. It's not going to be as easy to calculate on a computer or on a cell phone. They may give you decimal answers instead of fractions. So this is something to kind of play around with on your calculator. But you can always do these by hand as well, although that's not as easy. 4/20 reduces to 1/5, 5/20 reduces to 1/4. Multiply straight across to get a final answer of 1/20. Again, just find the probability of each event, multiply them. So number 3, find the probability of green, then purple. So the probability of selecting a green marble is 3/20. Purple is 8/20. I did reduce 8/20 to 2/5. Multiply straight across, you will get 3/50. And it is reduced. If you ended up getting 6/100, that reduces to 3/50. Number 4, find the probability of selecting purple, then blue. So the probability of selecting a purple marble is 8/20. Blue is 4/20. 8/20 reduces to 2/5. 4/20 to 1/5. Multiply straight across to get 2/25 for your final solution. All right, so we shift gears a little bit. So these are also independent events. A number cube is rolled and the spinner at the right is spun. Find each probability. So these are independent events. You roll a cube, you spin a spinner. Those are not impacting one another in any sort of way. Now, there are going to be some terms that you'll need to be familiar with down below. A prime number is a number that is divisible by only 1 and itself, including 2, 3, 5, 7, 11, 13, and so forth. 1, by the way, is not prime or composite. And 2 is the only even prime number. So we will have 1. It's going to be pretty easy. Number 6, we're looking at a standard 6-sided die. So when we look at prime numbers, they're pretty low numbers. We also talk about vowels and consonants. Remember vowels, A, E, I, O, U, and sometimes Y. Don't worry, I didn't include Y so that we wouldn't have to decide whether it's a vowel or not. And consonants are your non-vowels. So number 5, when I say P of 4 and D, it means what's the probability that I spin a 4 on the cube, or sorry, roll a 4 on the cube. I'll say that a lot probably. Roll a 4 on the cube and spin a D on the spinner that's at the right. So find the probability of each event and then multiply them. So when we talk about probability of the cube rolling or landing on 4, that will be 1 out of 6. For D, there's one section labeled D out of 8, so that's 1/8. 1/6 times 1/8 is 1/48. Number 6, probability that you roll a prime number and get a vowel on the spinner. So for a prime number, that's going to be numbers like 2, 3, and 5. 3 out of the 6 numbers, which is 1/2, by the way. On the spinner, when we talk about vowels, we have A and E. That's 2 out of 8, which is 1/4. Multiply straight across to get a final probability of 1/8. Number 7, probability of an odd number and a consonant. Well, you have a 3 out of 6 chance of getting an odd number, 1, 3, or 5. A consonant is everything that's not a vowel, so that would be 6 out of 8. 3, 6 reduces to 1/2. 6 eighths reduces to 3/4. Multiply straight across to get a probability of 3/8. Number 8, probability of getting an even number and a B. Well, even number is the same as odd number, 3 out of 6. B, there's only one section out of 8. 3/6 is 1/2. 1/2 times 1/8 is 1/16. All right, last 4 before I give you a chance to try a few of these independently. Number 9, we first need to read, it says a number cube is rolled and the spinner at the right is spun. Find each probability. We have to assume these are equal sizes. It's not perfect. I created this spinner a few years ago, but they're all equal sized. Probability of an even number on the cube and red on the spinner at the right. Well, even number is 3 out of 6. Red is 1 out of your 5 sections. So that's 1/2 times 1/5. These are pretty easy to do without using a calculator. You're going to get 1/10. Probability of the odd number and not blue. Oops. So an odd number, once again, is going to get us 1/2 or 3/6. Not blue is the 4 sections that are not blue, green, orange, red, or yellow. 1/2 times 4/5 is going to get us 4/10, which reduces to 2/5. Probability of 3 on your number cube, yellow on the spinner. So 3 is 1 out of 6, 1 out of the 6 sides. Yellow is going to be 1 out of 5. Multiply those to get 1/30. And finally, number 12, probability of 6 on your number cube and not green on the spinner. 6 on the number cube is 1 out of 6. Not green is 4 out of 5. This will multiply to get us, if you have 4/30, that's great, but it reduces to 2/15. All right. Oh, we still have 2 more. I forgot about these. So we have 13 and 14 and then independent practice. I believe you have a question or 2 similar to this on your independent practice or extra practice sheet. So you may want to make sure you pay particular attention to these. Number 13, a number cube is rolled and a letter is chosen from the word soccer. Find the probability of an odd number and an E. So an odd number on the number cube is going to be 3 out of 6. E in the word soccer is 1 out of 6, since you have a total of 6 letters, 2 of them being the same, but 6 letters in the word soccer. 3/6 is 1/2. 1/2 times 1/6 is 1/12. Number 14, a number cube is rolled and a letter is chosen from the word soccer. What's the probability of an even number and a C? Even number is going to be 3 out of 6 again. And for C, we have 2 C's out of 6 letters. So that's 1/2 times 1/3, which is 1/6. All right, now I do have some independent practice for you to try. Pause the video, read the directions, and try these 3 questions. All right, hopefully you paused the video. Let's go through these quickly. A jar contains 5 blue, 6 green, 8 yellow, and 1 orange marble. Once a marble is selected, it is replaced, which indicates this is independent probability. Find each probability. Number 1, the probability of blue, then yellow. You need to recognize that we have a total of 20 marbles. 5 are blue, so that's 5/20ths. 8 are yellow, that's 8/20ths. Multiply those, you will get 1/10. And again, that is your answer in simplest form. You want to make sure, several of you I know on your week 1 assignments were not writing fractions in simplest form, which even if you don't have a calculator, you can do by hand. Number 2, probability of orange, then green. Well, we have 1 out of 20 that are orange, and then we have 6 out of 20 that are green. Multiply those together, we do get a fairly large fraction here, 3/200ths. What about 2 greens in a row? Well, the probability of each green is 6/20ths. Take 6/20ths times 6/20ths, you will get 9/100ths. All right, hopefully you did pretty well on those. You will get a chance to do this on one of your assignments as well, very similar to these problems. Now, our next set of problems, oops, I forgot to hide this. Our next set of problems, we're going to have dependent events. So it says a jar contains 4 blue marbles, 3 green marbles, 5 yellow marbles, and 8 purple marbles. Once a marble is selected, it is not replaced. We have a total of 20 marbles here. I forgot to hide that. So add these together to get 20 marbles. How do you know that this represents a dependent event? Well, in this case, it's because once a marble is selected, it is not replaced. So this is going to be slightly different, so pay attention. Number 16, find the probability of blue, then yellow. So here's the deal. Now, I wrote this out in words again. You don't need to do this. But first things first, let's find the probability of selecting a blue marble. That's 4/20ths. But now the probability of yellow, this is following blue. You can say yellow after blue, yellow following blue, whatever. But the probability of selecting a yellow after choosing the blue, we have 5 yellow, but we only have 19. I'm going to highlight this. We only have 19 marbles left. We didn't take out all 4 of the blues. We took out 1 blue. We did not replace it. So now we have 19 marbles left. So it's not 4/20ths times 5/20ths. It's 4/20ths times 5/19ths, which is going to get us a final solution of 1/19. Number 17, what's the probability of selecting green, then purple? All right, so for green, we know that we have 3 green marbles out of 20. The purple, after taking out a green and not replacing it, we have 8 purple, but only 19 marbles left. So 3/20ths times 8/19ths is 6/95ths. Again, notice how we decrease this denominator by 1. Number 18, find the probability of purple, then blue. The probability of selecting a purple marble is going to be 8/20ths. That reduces to 2/5ths. But for the blue, we have 4 blue marbles, but only 19 left because remember we took one out. So we take our 2/5ths times 4/19ths, we will get 8/95ths. Now be really careful with 19 and 20. So the probability of selecting 2 yellow marbles in a row. The first yellow is going to be 5 out of 20. But for our second yellow, we choose a yellow after taking one out, so we only have 4 yellow left out of 19 total marbles. So you actually decrease both the numerator and the denominator here. 5/20ths is 1/4. 1/4 times 4/19ths gets us a probability of 1/19. It's actually the same as number 16 up here. That won't always happen. What about the probability of selecting 2 green marbles in a row? Well, the first green is 3/20ths, but then we only have 2 green marbles left out of your marbles that are in the container. We only have 19 marbles. So again, we decrease both the numerator and denominator. I took a green out, I didn't replace it. There's only 2 and only 19 left. When we multiply straight across here, we're going to get 3 1/90ths. And again, notice how we decreased both the numerator and the denominator when we chose two of the same color in a row. All right, I put some independent practice in here before we finish this video. Go ahead and give these three a try. Don't forget to pause the video. These are dependent probability. Okay, hopefully you paused the video and tried each of these. A jar contains 6 blue, 8 green, 7 yellow, and 4 orange marbles. Once a marble is selected, it is not replaced. Find each probability. Probability of blue, then yellow. Notice how we have 25 marbles this time. 6 are blue, so that's 6/25. The yellow is 7/24. Multiply straight across, you should get an answer of 7/100. Number 2, probability of orange, then green. Orange is 4/25. Green is 8/24, which by the way reduces to 1/3. Multiply straight across, you get 4/75. One thing I want to stress, I remember a mistake students make a lot of times in years past, is they think that after the first problem, for example, all of a sudden we go to now we have 23 marbles and 22. We start over with each new question. So we start with our original 25 marbles. That's just something to keep in mind. Number 3, probability of 2 greens in a row. The first green is 8/25. Our second green is 7/24. We multiply those to get 7/75 for our solution. All right, again, after watching this video, you may want to try assignment 1, which is a practice sheet on both independent and dependent probability. The top is independent, the bottom will be dependent probability. Definitely something for you to keep in mind. All right, thanks for listening.